Hello, calculus scholars. Today, we are going to actually be zooming in and going from average rate of change and the secant line to a new and improved measure of slope called the tangent line, or what we also call the derivative. So the essential question is, how do we find the slope of curvy things at a point? So let's say that we have a guy, we'll just call him like Slope Dude. And Slope Dude is on a slope, like a ski slope type of thing, and he's right there. And we want to know how steep he is on the hill at that point. Now, the secant line, we could, do the average rate of change. So this is like your, change in y over change in x, or, the f of b minus f of a over b minus a. So we could use, algebra to figure out what that slope is. But the problem is that it's only kind of an approximation of what the slope is that Slope Dude is experiencing, and it's not the exact slope. So naturally we want, we would get an even better estimation if we made those points closer to where Slope Dude is. And if we got like really, really close, we get even more exact. But the tangent line is the gold standard. So the tangent line, the slope of the tangent line is our derivative at a point. Okay. So the answer, the slope of a tangent line is going to give us that exact slope of a curve at a point, and we're going to refer to this as instantaneous slope. So at that moment, what is their slope? What is Slope Dude's slope at the point that he's at on the hill? And we will be computing this by learning how to compute the derivative, both in the one way first, to kind of give you a more conceptual understanding, and then the shorter way. So today on Delta Math, or next class, I should say, we're going to actually be able to draw tangent lines. You're going to also determine in graphs when you have horizontal and vertical tangents. You're going to determine parts of a graph where you can and cannot take derivatives, and then also estimate a derivative from a graph. So we're just going to focus at the graphical level today without looking at equations. And in the next class, we will be looking at equations. So here's some memories of Slope Dude. I played a video here. It actually is very illustrative, not only for, pre-algebra students learning about the concept of slope for the first time, but even in our study of derivatives.
Adventure of Slope Dude. Meet Slope Dude. He loves to ski. We are going to follow him, and he'll teach us some important aspects of slope.
You can even see a nice little advertisement on the bottom of the video.
What he said.
Oh, let's try that again.
Meet Slope Dude. He loves to ski. We are aspects of slope. This is the course in skiing today. Again, what he says will teach us about slope. You need to remember that Slope Dude always skis toward the right or eastward. When he starts out, he's going uphill. It's hard work. He says puff, puff, positive as he goes up the mountainside.
So Slope Dude at that point has a positive slope. And if we were kind of taking the derivative of that curve at that point, we'd also have like a positive number. And you can kind of see that I kind of wrote down rules translated with slopes and then converted them to derivatives. So please write those down on your notes.
Puff, puff, positive. Puff, puff, positive. Puff, puff, positive. Now he's at the top. It was puff, puff, positive all the way up the mountain. but now he can look forward to the downhill.
And actually, technically speaking, at that point, we're going to kind of assume that it's a little curved at the top, but his slope is kind of horizontal at that point. So it's actually zero slope at that instant.
On the way down the mountain, he says, nice, negative, nice, negative. And now, after the downhill, he's in for the hardest part of the ski run, the long, flat part. He says, this is zero fun. This is zero fun. This is zero fun. This is zero fun. And as he finishes the flat part, he doesn't see well ahead, and all of a sudden, he comes to the edge of a cliff. It's straight down. So frightened is he that he says the worst curse word possible in math and in algebra. Undefined.
So when you say undefined, what that means is not only can you not really get a real number when you're computing the slope, but you actually cannot compute the derivative when you kind of have an undefined slope. So other places where we can't take derivatives, sharp points on graphs. So if you have a situation like maybe the base of an absolute value function, so that's what I mean by a sharp point. Discontinuities, obviously, I mean, if we're kind of skipping around in the graph, we really can't take slope or instant slope right there. And then, of course, your vertical tangent lines, you cannot get a real number from those derivatives. So let's actually take a look at some delta math here. So the first exercise that I'm going to give you today is just drawing tangent lines. So what you're going to do here, it wants you to come up at that yellow point, right in that box of what a tangent line would be. So your goal is to approximate as much as possible what that slope is going to be. So your goal, you don't want the other yellow point to be far away. You want to get it as close as possible and best showing, what that slope is looking like. And then you zoom in. And we can kind of see that we need to lower that point ever so slightly. So here we kind of zoomed in. And that's pretty darn close. And as you can kind of see, this is like the box. And what I was able to do was I was able to zoom into the point where the tangent line looked like it pretty much approximated the real line. All right. The next exercise that I'm going to give you is finding horizontal and vertical tangents. So what we're kind of looking for these is looking for places where there are vertical tangent lines on the graph. So this just kind of means like undefined slope. So we can kind of see, well, let's see, we kind of have pretty nice clear cut. This is a like pointy thing type of situation. But when we get to right about there, we have a vertical tangent line. And we're going to put in the value. Of 1. And you may be saying, well, looking pretty close to vertical, as we're getting towards like 7. But keep in mind that at 7, we're kind of dealing with a discontinuity type of situation. rather than a vertical tangent line type of situation. Also, horizontal tangent lines are nice because that tells us where we have zero slope. So where that happens are not like pointy things, but kind of like right about there. Let me just erase that here for a second. Right about there. So I get -4. About 1. And then about 6. And you can just list the points. Or actually about 4. So -4, 1, and +4. We also are going to be looking in some exercises where you're going to determine differentiability from a graph. So thinking about places where the graph is not differentiable. Notice that -9 and 9 itself are not included. So in the interval that they want you to look at. So we're not going to look at the endpoints. But we could see is that at -7, we can't, and then put like a comma. So this will get you into like set notation. -1, you have a discontinuity. +2 is a discontinuity. And then +7, you have a vertical slope. And then the last exercises will be estimating the derivative from a graph. Now note that this symbol means f prime of 8. This means derivative at x equals 8. AKA, what is the slope at x equals 8? So I'm just going to go right to that graph here. So there's about x equals 8 right there. And we can see that it has a negative slope at that point. And it looks like we're kind of going from about, let's see, at -8, we may have went down about 1. But it's going to definitely be like a negative number. Then you just submit your answer. So it's below 0. Oh, it's -8. I mean, I was accidentally thinking about x equals 8. Yes, I should have read the question a little bit more carefully. But at -8, it is positive sloped at that point. And we'll just kind of do one more. If we do 8.5, positive 8.5, I'm going to go to 8.5 on my x-axis, go up, draw in that tangent line, and it is ever so slightly positive. So it's going to be a little bit above 0 at that point. And that's more like it. So that's what we're going to be doing on those exercises. So please stay tuned tomorrow for the equation side of things on the delta math. And we'll kind of go through that on the next scale.